So I just wanted to give you a little bit of an idea of what the research is that I'm doing this summer, so you have kind of an idea of what are our goals and what are we doing with these octopuses. And so what I'm interested in is how does ocean acidification impact the physiology of cephalopods. So there's a recent study that was published that suggested that octopuses and other cephalopods are doing really well. Their populations are growing all across the globe. And the likely explanation for this is that they're adapting to changing environments better than a lot of other animals are, and so they're seeing their populations grow. What I'm really interested in is why is this happening? How are octopuses able to adapt to changing environments, particularly increasing CO2 and decreasing pH in the ocean? So one of the interesting things that we found out just 2 years ago when I started this research here at Rosario Beach Marine Lab is that the CO2 out in the water here is actually really high. It actually turns out that if you look at the CO2, the water here at Rosario is about 750 microatmospheres. Most of surface ocean waters to be about 400. And what it was pre-industrially, before we started dumping CO2 out into the atmosphere, was somewhere like 285 microatmospheres. This is what it is near Rosario Beach Marine Lab. This 750 microatmospheres is about what we expect the ocean average to be at the end of this century, which is really interesting because what this means is that the water here around Rosario Beach makes a very interesting natural experiment in what higher CO2s can do to animals over a long period of time. One of the challenges of ocean acidification experiments is that it's really hard to keep these animals for long periods in captivity where we're adjusting the CO2 and particularly to keep them for multiple generations or their entire lifespan. I know with octopuses at least, especially the ones that I say, they have these planktonic larvae or their babies, they go up just into the water column and they spend as much as 6 months just swimming around in the water before they settle back down into the bottom of the ocean. And this type of life stage makes them really, really hard to culture in the lab, and even harder to culture in the lab if you're trying to modify their environment by sticking them in high CO2 or low pH. And so what's hard for us to do in the lab, nature has done for us right here by providing us this area of really high CO2. These octopuses have been living there likely their entire life, and maybe even for multiple generations. And what this means now is what I would have a hard time reproducing in the lab, I can just find out there. So what I am interested in doing is comparing how are the octopuses that live here near Rosario Beach, kind of in the Puget Sound, San Juan Islands area, compared to octopuses that live on the open coast where the CO2 is much lower. And so what I'm doing this summer is I am collecting octopuses. And I'm collecting them from the water around here. So I'm collecting them in 750 microatmospheres of CO2. And what I'm doing is I'm measuring their metabolic rate here at the beginning. I'm collecting 20 octopuses. When we measure the metabolic rate, you're going to take half of them and leave them. So 10 octopuses are going to stay for 1 month in this high 750 CO2. Another group of 10, I'm going to put down at about 400 microatmospheres of CO2. This is what the rest of the ocean is. Most of the rest of the ocean is right now, about 400 microatmospheres. What we have found from previous work is that our octopuses around here are actually really well adapted to higher CO2. We can crank up the CO2 even up to 1,500 microatmospheres. It does not affect them too much. They're doing A-okay. So what I'm really curious is this because they're living in the 750? And if so, can it be that if we lower them back down, will they lose this adaptation? So we measure the metabolic rate here, and then again at the end, we're going to take their metabolic rate again. So we have a beginning with all of them. Take half of them, leave them in the 750, take another half of them and lower them down to 400 microatmospheres. them there for a month and then see what is their metabolic rate like at the end of this month, and trying to see if these lose their adaptation. One thing I should mention is when we take their metabolic rate, we are putting them in respirometers and we're taking them back up to 750 microatmospheres and seeing how they're doing. So these ones, we're measuring all of them right here at 750 microatmospheres. We're going to measure their metabolic rate. We're going to take half and just leave them in that and measure their metabolic rate again at 750 atmospheres. The other ones we're going to take, we're going to lower down to 400 microatmospheres. We're going to leave them there for a month. And then when we do this, we're going to bring them back up to 750 microatmospheres and then measure their metabolic rate again. I'm curious, do these ones that we take down, do they lose their adaptive ability to handle the 750 microatmospheres if we leave it? Not doing this summer, but this upcoming academic year, I'm going to obtain some octopuses from the open coast at 400 microatmospheres. And what we're going to do with them is the exact same thing, measure their metabolic rate here. And then do essentially the same thing. We're going to take 10 octopuses, bring them up to 750, leave 10 octopuses down here at 400 microatmospheres, and do essentially the exact same thing. So I'm really kind of interested in, at the beginning, if these ones have been living their entire life at 400 microatmospheres, if we measure them again at 750 microatmospheres, how well adapted are they for us to put them into that and look at their metabolic rate? And then after a month of half of them being out there, have they gained some immunity, so to speak? Not exactly immunity, but have they gained some resistance to the higher CO2 after we've had some of them in that kind of environment for a month as opposed to the other ones? So I'm really kind of interested, how differently are these adapted? What we were doing last year is having 700 as kind of our control tanks, which is what we were pulling the octopuses out of, and a 1500 per million treatment, which is kind of maybe future Puget Sound. What we're doing this year is actually doing the 700, and we're going to be reducing the CO2 in some of the tanks, getting it down to like about 400, what the rest of the ocean's at, and seeing how do they do in that. Do they do better? Do they actually lose their adaptation to the high CO2? So we actually need to get the CO2 lower than what it is in the water. We're going to do that by bubbling.
I'm going to be setting up this Mongo air pump, which I'm going to take out and attach to the 2 beach tanks, because those are the tanks that we want to keep at a lower CO2 level. It's a lot of bubbling. It works! I set up a really big air pump into the beach lab, and if you remember, I got that tank bubbling really hard. I ran some pH and titrations today, and we got to about 420 after just a day of bubbling. So I think that if I add a couple more lines in there of air going into the tanks, that we can get to about 400. So let's go check these tanks out. I can add 3 more, because I've spots for 3 more, so I'm going to go find a few more lines and it'll be good.